Hello everyone, welcome to 360DigiTMG. Today we are diving into a fascinating world of foundation models, which are the core of some of the most advanced AI systems we see today. These models are large, pre-trained neural networks that serves as a backbone for various applications from natural language processing to computer vision. Okay, by understanding the structures and capabilities of these models, we can appreciate how they power everything from chatbots to autonomous vehicles, making AI more accessible and impactful across different industries. So, so let's explore how these models work. So today we are going to discuss about few of the foundation models. So this is our agenda. See, we as we know all these foundation models in this foundation models our data will be from like different domains. It can be from different domains like from text, images, speech, structured data like from databases or spreadsheets or so on and so forth, and 3D signals like data from sensors or 3D imaging technologies. Okay, so after getting all these data, what we'll do, we will feed that data into a model, allowing our model to learn patterns, structures, and relationship between the data. Okay. After training our data, or after training this our data, what we'll do, we will, as there is a uh, the foundation model present. What is foundation model called? Foundation model is a pre-trained model. Okay, our pre-trained model has already us having new all the pre-trained neural networks are already there that serves as a base for various applications. Okay, as in how we want that to be applied, we can apply that. And it has learned general representations from the input data types during the training. Okay, after that after that, in the adaptation phase, our foundation model has been adapted, or we can fine tune for a specific task. Like if we want for a specific task, like for question answering, if we want for question answering our model to be trained for a question answering task, or for a sentiment analysis task, or for information extraction, or image captioning, or object recognitions, or instruction following. Like these are the tasks we can train our model on. So we can either fine tune that model for a specific task, or we can apply the foundation model as is also and adapt that model into for a specific task. Okay. So what we are eventually doing here, we are getting a data, we are collecting a data, and our data can be from different formats. Okay, we are training that data into we are feeding that data into a model, and we are training according to a patterns. Okay, and after that we are converting into our pre-trained model. uh, we are adapting it to our pre-trained model, and whatever the task we want, we can have that task from that our foundation models. Okay, so this is how our foundation model works. So here, firstly, we are going to see about T5, that is text to text or transfer transformer. Okay, T5 or text to text transfer transformer is a powerful large language model developed by Google AI. It uses a text to text format for various tasks, making it versatile and adaptable. Okay, so what it means? This means that both the input and the output of the model will be in text format, text to text. Okay, which makes the T5 very versatile and adaptable to different tasks, such as it can be used for translation, it can be used for summarization, it can be used for question answering, and so on and so forth. Okay, there are key parameters in it. So let's see the key parameters. Here, embedding size. So here embedding size are dimension for each tokens. Token means, what is mean by token? Token can be of words, or here we are initializing as in word or subwords. Okay, so dimensions of each token's representations should be of 510, 512 or 1024. Okay, it should be 512 to 1024, which indicates that it has different configurations of the models where the embedding size can vary. This embedding size can vary from 512 to 1024. Okay. Then there is hidden size. For hidden size, there are a dimension of internal state vectors in the transformer layers, which is having 768. Means that what it means, 768 means that the vector processed within each layer for the model has 768 components, internal hidden components. Okay, 768 components there are. And then there are numbers of layers. Numbers of layers, what is saying? Stack transformer layers is 12. What it means? The model might have 12 layers, each of which processes the data sequentially to improve the quality of generated outputs. Okay. Then there is technical details. Technical details. In the technical details, there is encoder-decoder architecture. Okay. So what it is saying? T5 uses an encoder-decoder architecture. The encoder processes the input text while the decoder generates the output based on the encoded representations. So let's see what is encoder and what is meant by decoder. Encoder means encoder takes the input text and processes it into the encoded representations, which is compressed form of input that captures its meaning. Okay. And what decoder will do? The decoder then takes this encoded representation and generates its output text based on it. Okay. The encoder-decoder structure allows the model to transform the input text into a suitable output. Okay. Whether it will be translating a language, it can be used for translating language, like it will adapt it from input text, process it, and then it will capture it, and then what decoder will do? Decoder will generate the output. Okay, and it can be used for what? It can be used for translating languages. It can be used for summarization, for question answering, likewise. Okay, in summary, what we can say for T5? T5 is a flexible and powerful model capable of performing a wide range of text-based tasks. Text-based. Okay. Then, by leveraging what? By leveraging its text-to-text format and the encoder-decoder architecture. Okay. So let's get. So here again, there is pre-training task also is there. Okay. So pre-training task, what is in pre-training task? There is a mask language modeling. Mask language modeling is, what does mean by mask language modeling? So what it does, randomly masking tokens and predicting them from the context. Like, what is its purpose then? Mask language modeling, why we do this? So this technique is used to train the model by randomly masking some of the tokens. What is token? Token is words or subwords in the sentences. Okay, whatever the sentence it has, okay, there will be words or subwords in that. That is called as tokens. Okay, and then what we'll do? We will mask some of the tokens and then asking the model to predict the mask token based on the context provided by the surrounding tokens. For example, we can say the cat sat on the, suppose there is a mask on it. Okay, so the whatever the prediction we can have, like the cat sat on the mat. Okay, So the mask word was mat. Okay. So this is how mask language modeling works. After that, there is denoising auto-encoding. Denoising auto-encoding, what is its purpose? So denoising auto-encoding, DAE, is used to add noise to the input text. Whatever the text we have, we will add the noise in it. Okay. And then train the model to reconstruct the original noise-free text. Okay. So why we do this? So this will help the model learn to handle various forms of noise and improves its robustness. For example, if you want to add the noise in the sentence, the cat sat on the mat. If you want to add the noise in that, so we can add hashtags or we can add the at, like that things. Okay, exclamatory and all. We can add noise in that sentence and we can decode it by the original by the original statement, that is the cat sat on the mat. So we are purposefully, what we are doing, we are purposefully adding the noise in it. Okay. And then there is text infilling. In text infilling, the model is trained to predict missing text spans, like within a contiguous block of text. The model learns to fill in the gap based on the surrounding context. For example, the cat mask on the mat. Like what we are doing, there are some contiguous block within the statement, and what we have to do, we have to fill that by using this text infilling. Okay. So this is how it is. Then after that, there is fine tuning. Okay. Fine tuning, after pre-training on general task, the model is fine tuned on a specific task. Okay. Like translation, summarization, or sentiment analysis. Fine tuning requires much less data compared to training from scratch. Yeah. Fine tuning will require much less data as compared to that of training from scratch. And pre-trained models adapt to new tasks quickly. Yes. Okay. So T5, now there is T5 versatility. T5 versatility allows fine tuning for various tasks with minimal additional data. Yeah. In summary, what we can say, this pre-training task prepares the T5 model to understand and generate text effectively. Like fine-tuning then customizes the model for specific task. Firstly, what we are doing, we are fine-tuning it and customizing the model into a specific task, making it a versatile tool for a wide range of natural language processing applications. Okay, so let's get proceeded. Then there is Canine Transformer Model. So Canine Transformer Model is a large language model from Google AI trained on massive data sets of text and code. Earlier, T5 was on only text. And now this Canine Transformer Model is on massive data sets of text and code also. It's unique in that it operates directly on character sequences without needing explicit tokenization or vocabulary. This makes it more efficient and flexible than other LLMs, especially when dealing with languages with complex or non-standard writing systems. Okay, so what it is saying? It is developed by Google AI. Okay, and it designed to handle the text at the character level. Earlier in T5, we are working on tokens. Okay, like words or subwords. Here in Canine Transformer, it is focusing on character level rather than words or subwords. Okay, so here are some character level inputs. Okay, in character level inputs, instead of breaking text into words or subwords, Canine processes each character individually. This allows it to handle languages with diverse scripts and complex morphologies, as well as emojis and other linguistic symbols. Then, deep transformer encoder. Canine uses a deep stack of transformer layers to extract meanings from the sequence of character. It will extract the meaning of sequence of character. Whatever the character we are extracting will have the meaning of that extracted character. These layers attends to each other, allowing them to learn long-range dependencies and relationship within that within the text. Then there is soft inductive biases. So what it does, even though Canine doesn't rely on fixed vocabulary, it can learn to recognize common subwords units like prefix or suffix or root words. Okay, like that. Now, after that, there is downsampling. In downsampling, Canine uses a downsampling to manage the longer sequences that result from character level processing, which will what do? Which will reduce the numbers of characters while retaining the essential information. And then there is multilingual pre-training. Canine is pre-trained on massive data sets of text in 104 languages. This allows it to perform well on tasks in varieties of languages, even those with limited training data. Okay, so this is all about Canine transformer model. Then there is machine translation. It can have machine translation. Machine translation. Canine can be used to translate between languages. Translate text between languages, even if they have different writing systems. Then it can be used for text summarizations. Canine can be used to generate summaries of long pieces of text, capturing the key points and information. Then for question answering, Canine can be used to answer questions about the text. Whatever the text they have, we can have a question answering also on that text part. If they are open-ended or challenging, even if they are open-ended and challenging also, we can have from that particular text, we can have a question answering from that text. Then natural language understanding. Canine can be used to understand the meaning of text, including things like sentiment, sarcasm, and humors. Then there is what we can say about Canine then. Canine model sounds out due to its ability to handle text at the character level. Earlier it was on token levels. Yes, here it is on character level, making it highly flexible and efficient, especially for languages with complex scripts or symbols. Its combination of deep learning, multilingual pre-training, and innovative processing techniques allows it to excel in various natural language processing tasks. Okay, so this is all about Canine. Now there is TAPAS. So it stands for table parsing by pre-training, and it's not actually a single large language model. So let's see about it. So this stands out for it is specialized model designed for specifically for tasks involving on tabular data. As we can say, the name suggests TAPAS, that is table parsing. Table parsing means it is for tabular data. Okay. Unlike general purpose, large language models like TAPAS is optimized to understand and work with structure and content of tables, making it particularly effective for tasks like question answering from tabular data. Then these are some of the key features. So first is dimensionality and architecture hyperparameters. So here there are embedding size and number of transformer layers. So embedding size, there are dimension of each token. Dimension of each tokens ranges from 128 to 512 with hidden layers ranging from 512 to 768 dimensions. This determines how each tokens or elements within the table is represented in a high dimensional space. Okay. Then there is number of transformer layers. So this tapas uses usually include 6 to 12 transformer layers, which are crucial for capturing complex relationships and dependencies within the tabular data. Okay. So there are table specific designs. There are table specific first. Tapas is specifically designed for dealing with the structure and information contained in a table. This allows it to outperform general purpose like LLMs on tasks like question answering from tabular data. Then there is efficient. The pre-training techniques like masked language modeling contributes to efficient learning and improved accuracy even with limited training data. And there is flexibility. Then tapas can be combined with different downstream task-specific modules for various applications. Like it can be used for question answering, document summarizations, and data extractions from tables. This is very important, from tables. Okay. So this is all about tapas. So what we can say about tapas then? Tapas is a highly specialized model designed to excel a task involving tabular data. Its architecture and training techniques makes it particularly effective for understanding and processing tables, allowing it to outperform more general purpose LLMs in these areas. Its ability to efficiently learn from limited data and adapt to different tasks adds it to its utility in applications where tables are the primary source of the information. Then there is Plan T5. Plan T5 is an Plan T5 is built upon T5 foundation, which is an improved performance on NLP tasks like answering, summarization, and translations. It is fine-tuned on diverse sets of tasks instead of just one, leading to broader knowledge and adaptability. Okay, it comes in larger model sizes compared to base T5, allowing it to capture more complex relationships within languages. Okay, so Flan T5 builds on original T5 model, okay, which is known for its versatility in handling various NLP tasks by converting all the tasks into a text-to-text formats. Okay, now it is improved. It has an improved performance over T5 model. By leveraging this foundation, Plan T5 improves over T5. How? By making it more effective in tasks like question answering, like summarization and all. Okay. Now it uses what? It uses a reformer attention mechanisms. Reformer attention mechanism. What it will do? It will help reduces the memory uses and training time by replacing the transformer layers. By replacing a transformer layer without any changes in its performance. Okay. This technique saves memory and only storing a subsets of gradient during back propagations, making training computationality flexible for larger models. Okay. Then there is unified text-to-text framework. Like Plan T5 stays true to T5 core principle. What was the core principle of T5? It will stay to that only. That is, Plan T5 will stay to that principle only. Like allowing the fine tuning for various downstream tasks with minimal adjustment. Okay. So this is all about Plan T5. And what will be the summary for that then? Plan T5 will have enhances the capabilities of original T5 model. Yes, by fine tuning it on diverse sets of tasks. Yes, increasing its capability and scaling up its size to handle more complex languages. The introduction of reformer attention mechanisms and memory efficient backpropagation techniques allows for more efficient training of larger models, making Plant T5 a powerful tool for a wide range of NLP applications. Okay. Now there is again one more, that is by T5. By T5. What is by T5? By T5 is a tokenizer free extension model. Okay. By T5 is it? By T5 model is a tokenizer free extension model, which extension of MT5. MT5 means multilingual T5 model. Okay. It is designed to handle raw byte sequences of text without the need for any pre-processing. This approach brings the several unique benefits and adaptations to the models. Okay, what it will do? It is not taking tokens. It is not taking tokens with respect to words, or with respect to subwords, or with respect to characters. It is not related to tables also. So what it is doing? It is taking bytes instead of doing tokens and all. Okay, so how it is doing? It will token free processing. See, token free processing. Unlike traditional models, they rely on tokenizations, breaking down text into words or subwords. By T5 operates directly on the raw byte sequences of text. It processes the text as a series of UTF-8 encoded bytes. Okay, it will directly convert into a byte. So this will eliminate. What will happen then? There will be no pre-processing required. Okay. So since T5 works with raw bytes, it eliminates the need for separate tokenizer. Okay. So this makes the model capable of working with any languages without requiring language specific tokenization rules. Yes. After that, okay, this is what it means for token free. Okay. And then there is modified transformer. Modified transformer. What it says? While based on the transformer architecture, by T5 implements adaptations like byte pair encoding and residual connections to efficiently analyze the long sequence of bytes. Okay. So what is byte pair encoding? So byte pair encoding means although T5 operates on bytes instead of tokens, it utilizes the byte pair encoding, that is BPE, we can say, okay, as a part of its processing. So what it will do? It will help to reduce the sequence length. It will help to reduce the sequence length by merging frequent byte pairs, by merging the frequent byte pair. Whatever the frequent byte pair, it will merge that, making the processing more efficient. Okay. After that, it will be used for residual connection. So what is residual connections? So residual connection within its transformer layer. Okay. These connections what will do? These connections will help the model maintain information across its layers. Okay, enabling more effective learning and efficient processing of long byte sequences. Okay, this is all about modified transformer. We'll see next slide about more about this byte pair encoding and residual connections in simpler words. Okay, what are the advantages of this then? So it can be language agnostic, that works with any language without needing specific tokenizer. That is the biggest advantage. Then robust to noise. It will handle typos, emojis, and other non-standard text better than token-based models. Yeah. And then efficient learning. Efficient learning like byte pair encoding, BPE means byte pair encoding and residual connections enables efficient processing of long byte sequences. Okay. So these are the key components of it by T5. So it will have an encoder-decoder structure. By T5 has an encoder that processes the input, whatever the sentence we have, whatever the text we have, it will convert into a bytes, and decoder then generates the desired output, like text or code. Whatever the text, we can generate it into a output, whatever the desired output we want. Okay, like text on code. Then byte pair encoding. See, here also it is. Okay, byte pair encoding and residual connection. What is it? So this technique, what it will do, the it will break down the frequent byte sequences into a smaller units. Okay, and increasing the vocabulary size without exploding model complexity. Okay, and residual connections will what it will do. So these bypass some layers in the networks, directly feeding the information to later layers and improving the information flow through the long byte sequences. This will save time also, and this will save the complexity of the model also. After that, there will be attention mechanism. As in transformer, attention allows the model to focus on relevant parts of the inputs during encoding and decoding, enhancing the processing accuracy. Okay, so there are some of the cons also. Here there are some of the advantages, as we have seen the advantages. Now there are some cons, like it will have high computational cost. Yes. And it will require fine tuning as it was pre-trained on unsupervised data. Yes. So by T5, what we can see about by T5? By T5 is a powerful extensions of MT5, multilingual T5 model that simplifies text processing by working directly with raw bytes. Its token-free design allows it to handle any languages and makes it more robust to non-standard text inputs. The modification to the transformer architecture, including byte pair encoding and residual connections, enables efficient learning and processing of long byte sequences, making by T5 a versatile and effective model for multilingual and noisy text tasks. Okay. So this is all about byte T5. Now it is UL2. UL2. UL2 is universal effectiveness. Universal effectiveness UL2 aims to be truly versatile model, performing well across various data sets and tasks without needing individual pre-training for each. Then it will combine multiple pre-training paradigms into one, allowing the model to learn from diverse sources of information. Okay. It will introduce a mode switching concepts where the model can adapt its pre-training adapts its pre-training focus to different downstream tasks. Large-scale pre-training. UL2 models are typically trained on massive data sets like T4 containing billions of words. Okay, so we'll see this UL2 in the next lecture. This is all for today. Okay, thank you so much. Let's continue in next lecture. Okay.